Hi everyone, welcome to 24 Hours of Pass Summit Preview 2016. We're excited you could join us today for Vicky Harp's session, Understanding and Monitoring Tempdb. This 24 Hours of Pass event consists of 24 consecutive live webinars delivered by expert speakers from the Pass community. The sessions will be recorded and posted online after the event. To access on-demand sessions, please visit www.24hoursofpass.com for all session links. My name is John Stinchcomb. I'm a DBA in the San Diego area, and I just have a few introductory slides before I hand over the reins to Vicky. If you require technical assistance, please type your question into the question pane located on the right side of your screen and someone will assist you. This question pane is also where you may ask any questions throughout the presentation. Please feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I'll read your questions aloud to the speaker. You are able to zoom in on the presentation content by using the zoom button located on the top of the presentation window. Please note that there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. It will appear in your web browser once we're done. I'd like to take a moment to thank our presenting sponsors, Microsoft, Attunity, and Idera. Idera's award-winning SQL Server database solutions and multi-platform database application and cloud monitoring tools ensure your business never slows down. Please check out the handout in the pane in your control panel for more information on Idera. In addition, I'd also like to thank the supporting sponsors for this event, Hewlett-Packard Enterprise and SQL Sentry. The staging of 24 Hours of Pass would not be possible without their generous support, and they are the reason this event is available free of charge. Make sure you explore everything else Pass has to offer for data professionals. You can join local user groups around the world, special interest groups, find free online resources through our Learning Center, read up on the latest community news in the Connector newsletter. Next, I'd like to bring your attention to the upcoming Pass Summit. Taking place in Seattle, Washington from October 25th to 28th, Pass Summit 2016 features over 200 sessions with world-class data experts. It's the perfect place to network with experts and peers, and you can meet the Microsoft engineering team behind SQL Server 2016. Save $200 in registration by using the exclusive discount code 24HOP200 before the end of Sunday, September 18th. To find out more, visit www.passsummit.com. Now, without further ado, I'd like to introduce today's speaker, Vicky Harp. Vicky has 15 years of professional software development experience and works at product strategy and research at Idera. Vicky frequently speaks at Pass events, blogs at vickyharp.com, and is active on Twitter. So now, without further ado, here's Vicky with Understanding and Monitoring Tempdb.
Hello everybody, thanks so much for attending today. This is one of my favorite topics, so I'm really excited to be sharing it with you today. So the first thing that I always get asked whenever people understand that I am having a presentation about this is, what is Tempdb and how does it differ from any other sort of system database that we have? So we have these main system databases, Master, Model, MSD, and Tempdb, which are actually part of every single SQL Server installation going back every version of SQL Server, at least starting since 7. Each of these system databases has certain particular uses within the operation of SQL Server, and all of them have different ways that you might need to maintain them or analyze them. But Tempdb is by far the one that people have the most problems with. And so in the course of today's presentation, I'm going to cover what it is, why you need to monitor, and some of the techniques that you can use to monitor it and make sure that it's not impacting your workloads. One of the great things about this topic is that Tempdb being part of every single SQL Server means that when you learn this, this is something that you can apply to small instances, to large instances, and from business to business, job to job. So I really hope that you get something out of this. So how temporary is it? So Tempdb is a special database which is recreated on server restart in SQL Server. When the server restarts, it reverts to the last configured size, and it's populated with the contents of the model database. So all of the settings and all of the objects that you put in your model database are actually moved into the Tempdb database on server restart. And even though your Tempdb might change during the course of it, you'll have objects created in it, you'll have changes to the size, maybe you have autogrow occur. Whenever you restart, it's emptied out and it reverts to the last configured size, and all of the contents are deleted. So it is fully temporary. It does not run recovery. So unlike the rest of the databases in SQL Server, which have a transaction log which is used to run recovery through restart, there is no recovery run with Tempdb. It's just started. That might bring up the question, why is there a transaction log at all for Tempdb? And the reason is that because you do still have transactions occurring, you might still want to roll forward and roll back within the course of doing your work and the transactions that you explicitly have occurring during the course of working with Tempdb or working with your system. However, that transaction log is then not used later for the purposes of recovery. So why would you want to monitor it? So Tempdb is used for a lot of different system activities, and the one that most people know about is probably temp tables. Those are the tables that start with the pound sign that you use to kind of temporarily move items maybe in the course of your stored procedures and your queries. It's also the backing database for table variables. What not as many people realize is that it has a lot of other purposes. It's used for cursors, it's used for after triggers, it's used whenever you do an online index rebuild, data is moved over into Tempdb. It's used for the transaction isolation version store, which I'll be covering in some more detail, and it's used for DBCC CheckDB during the course of integrity checks. Some of these are really intensive. DBCC CheckDB makes very active use of Tempdb, and so there's a lot of activities going on in here, and they're cross-database in nature. So even though you might have transactions running on your prod DBA and your prod DBB, they're both using the same instance of Tempdb. So whenever you have a problem with Tempdb, it can slow down all of these disparate considerations within your server. So you can have slowdowns that are occurring due to Tempdb contention, or you have issues occurring because CheckDB is running, and that's affecting how fast your stored procedures are running because of temp tables. It's affecting other aspects like the speed with which you're able to create new objects. And so this is something that if you monitor and you can get it running smoothly, you remove that sort of overhead from your entire system. So the Tempdb issues we're going to be covering today are these four. This is actually a topic I could go on for 90 minutes, 2 hours at least. But the ones we're going to cover today are issues of file topology, contention, version store, and session space usage. So we'll step through each of these in turn, starting with file topology. So when I'm talking about file topology, I'm talking about the actual allocation of the files, the size of them, the location, etc. within the system. So by default, prior to SQL 2016, whenever you install SQL Server, you get one 8 megabyte data file located on the C drive, one 1 megabyte log file on the C drive, and they're set up with 10% auto grow. Unfortunately, and we'll talk about SQL 2016 later, unfortunately, the best practices are entirely different. What you actually want to have are multiple pre-sized data files on a non-system drive, one log file on a non-system drive, and fixed-sized autogrow. So all of these sizes that are preset and the way that autogrow is set up is not going to be very performant when you're dealing with prior to SQL 2016. So the question that I get a lot is, what size file should I use? So one way you can kind of work that out is use DBCC CheckDB with estimate only, which will kind of give you the size of how much space DBCC CheckDB is going to use. Run it against your largest database, get an idea of how much space it's going to use in Tempdb. Make sure Tempdb is at least that large, probably much larger, because when you're running your integrity check, you're going to have other workloads running and you want to have some head space. You can also check the index size of the largest index that you're going to rebuild. So if you have a very large index, you're rebuilding it, it's online, that index is going to be using space in Tempdb during the rebuild process. So you'll want to make sure that your Tempdb is at least large enough to hold that. But most importantly, I want you to monitor, and I want you to take a look and see where your Tempdb kind of winds up baselining itself to after the server has been online and gone through a normal business cycle workload. So it doesn't really work if you just turn on the server, wait 15 minutes, take a look at what size the files are. You need to make sure that all of the major backups and restores and all of your major jobs and ETL, etc. have gone through. Take a look and see what size everything seems to stabilize to, and then you should be setting it up so that when you start the SQL Server, that is the size. You're not having to go through an autogrow process to get to that every time you restart the SQL Server. So in terms of monitoring, I want you to be checking the file location, the file count, and the available space. Now, the reason I want to say file location is because when you're talking about the locations of the file, by default they're on the C drive or the system drive, which is not the best situation to be in. For one thing, that might not be really very fast hardware. It might not be the hardware that you would expect for your databases to be running on, and you shouldn't be skimping on Tempdb just because it's temporary data. It is something that you would like to have run faster. Also, anything that you have on the system drive, it kind of gives you the possibility, if this were to grow out of control, would it cause problems for your actual Windows installation on which the server is running. So I would like to see it on a non-system drive, but at least you should know where it's at and make sure that you're aware of it. When you take a look at the file count, we'll be going into more detail about how many files you should have in the future, but something that you should know is that when the server restarts, the file count could actually change, and I'll give you a demo of that. So I want you to monitor to make sure that the file count is appropriate and that it's not changing unexpectedly. And I want you to check the available space. If it's running very low on space, if you're running into situations where it's auto-growing frequently, you're going to have the overhead of whatever activity it was that was trying to occur in Tempdb that caused that growth to occur. It's going to be slowed down by that. So try to leave some headroom so that you can have all of your operations occurring without auto-grow. I want you to check this every 5 seconds forever. Not really. I want you to check it after a server restart and up to hourly for space available. It's something that really depends on your workload and what type of monitoring you're doing. But at the very least, I want you to check this after server restart to make sure everything is where you want it to be. When you're monitoring the files, the system views that you can use are DMDB file space usage and sysdatabase files. Now, all of this demo that I'm going to be doing and all of the demos that I have are uploaded for you to be able to download and use, so don't feel the need to take detailed notes about which DMVs to use. You can just take my scripts. So let's jump over. So I want to give you a sense of the server we're going to be working with. I'm using a SQL 2014 instance. It's got 4 cores. It's got 2 gig memory. This is virtualized, and it is running, like I said, SQL 2014. And I will pop over here. This is my file topology query. So I am querying from DMDB file space usage joined on Tempdb sys database files on the file ID. So I'm getting a couple of things: the name, the physical name, the size in MB, and then all of these are calculations based on reserved page counts. So I've got user objects, internal objects, the version store, mixed extents, and free space. Some of these we're going to be covering in a little more detail. User objects and internal objects are probably a little self-explanatory. User objects are related to user sessions and objects you're creating. Internal objects are internal sessions, things created by system activity. The version store is the transaction isolation version store, which we'll be covering in greater detail. And mixed extents are a section of the file which could be a mix of these different types of objects, and we'll cover that as well. So when I run this, you'll see I currently have 4 data files. They're all located on the C drive. You have to slap my hand, but that's the way my VM is set up. They're all the same size, 16 meg, and they have kind of a mix of similar space free and similar usage. So that's fine, and I would be taking a look at that, and in this case, you know, I've got a lot of space free. The server isn't doing much. I'd be pretty comfortable with this. In a real environment, these would be much larger. But I want to show you what happens if I restart the server and those files aren't able to be used. So let me stop my server. And here I've got my files, tempdev 2, 3, 4, tempdb, tempdev 2, 3, and 4. So I'm going to take these, I'm going to set them to read only. And then I'm going to restart my server. Now if I go over to my log, pull up the error log, we've got kind of normal activity occurring here. I'm going to scroll down a little so you can kind of read this. So we've got our startups occurring, and then we have down here starting up model and then clearing Tempdb database. So that's where I was saying Tempdb gets a copy of the model database, starts up Tempdb, and then I start getting these errors here. on the create file. So you can see it wasn't able to open the Tempdb 3, and it tried twice trying to open it. Access is denied. And then it moved on. It did not fail to start. However, if I go over and run my little monitoring query again, you're going to see we are now down to one file. So when it was unable to open that next file, and which was Tempdb 3, it gave up. It failed back to the single file in the default location. So SQL Server will try very hard to not let problems with Tempdb cause it not to start. However, if you weren't aware of this, if you had this set up with 8, 16 files, etc., and you were expecting that to continue, and you had a problem with corruption or a problem with access or drive access, you might not realize that something had gone wrong. So this is one reason that I want you to monitor it. And for the purposes of the rest of our demo, I'm going to leave it with this one file so that you can see the sorts of problems that you might run into. So that leads us directly into the problem of contention. Contention is the thing you probably hear the most about in terms of Tempdb problems, and it's something that really to get a good understanding of, you're going to have to understand SQL Server Allocation 101. So when I'm talking about SQL Server Allocation, I'm talking about the storage engine's process for determining where the bits that you're storing are actually going to be located physically on a disk somewhere, magnetic, SSD, whatever it happens to be. So there are all these logical units in SQL Server Allocation. At the highest level, you have the database, all the way down to the page and the record. And in between, we have these concepts that some people are more or less familiar with. The file group, which includes groups of files, most people are fairly familiar with. Extents, people might have heard tossed around, but they're not quite as sure what it means. And you've got pages and records. For the purposes of this conversation, we really only need to talk about files, extents, and pages. So records are the actual individual rows that you're storing. They are stored on something called a page, which is an 8 kilobyte structure. So the page record has a page header, which is 96 bytes, row data of 8096 bytes, and all of this together is 8192 bytes. And this is the fundamental storage unit for SQL Server. So whenever people are talking about pages, they're always talking about this same structure. That includes in Tempdb. Now a group of 8 of those pages is called an extent. So we've got pages 1, 2, 3, 4, 5, 6, 7, 8. Technically it would be page 0, etc. But pages 1 through 8 are going to go into an extent, which is 64 kilobytes. Now that's something that you can use to say, when you're trying to locate a file, you might say which extent it is within the file rather than which exact page number. Now, mixed and dedicated extents. This is something that we have to go back to earlier versions of SQL Server, and you think about 8 kilobytes now doesn't sound like very much. 64 kilobytes certainly doesn't sound like very much. But that was a lot of space when you're talking about SQL 2000 and enterprise storage. SQL 7 enterprise storage. This was not storage that you wanted to waste. So the way that SQL Server Storage Engine is set up, at least prior to SQL 2016 for Tempdb, is the first extent is actually shared among objects. So imagine that you had a table you were going to create that was only going to be about 16K in size. Well, going back to when storage was more expensive, you wouldn't want to necessarily set aside an entire 64 kilobyte region for that table if you were only going to use 16K of it. So instead, the first couple allocations occur in something called a mixed extent. So here we've got an example where table A takes 3 pages. And then after that, it goes ahead and gets its own extent, and the rest of its pages come from that extent. And then the same occurs with table B and table C. So all of these tables have this large extent, 64K boundaries, where the storage is all to itself, except for this first extent, where it's got a couple pages mixed in. That's something to be aware of, and that goes back to what I was saying earlier with those mixed extents could have a mix of types. That could have both internal and user objects. It could have objects for different purposes. Something else to know about allocation is something called a GAM interval. So a GAM interval is a 4 gigabyte section of numbered extents from 1 to 63,999. And the GAM page at the beginning of that page interval keeps track of the allocation state of each extent. This feels like a real handful, so bear with me. When SQL Server is doing an allocation, it's going to look up this GAM page and identify where in the next 4 gigabytes do I have an unallocated page. So, or an unallocated extent that I can get new data from. So you have a new object that's going to be created. We need to find space for it. The GAM page tells you where all of those pages are in the next 4 gigabytes. The SGAM page keeps track of the free pages in the mixed extents. So say we're creating a new object. We want to look for a mixed extent to stick those first couple pages into. It's going to look for the GAM page to see the allocation state and the SGAM page to see which mixed extents are free that have a little space to put into them. The third page that we have that we're taking a look at whenever we do allocation is called a PFS. So a PFS interval is 64 meg, and it keeps track of the free space in heap and lob pages. Now that sounds like a lot to cover, but if you think about it, Tempdb specifically, taking us back, most of the time when you're creating Tempdb objects, are you probably creating indexed objects or heap objects? They're probably heaps. So you're probably just creating simple tables, or you have simple things falling into Tempdb that do not have complex structures. So when you have an index, then where those pages need to be allocated is going to be ordered based on the index structure. But when you have a heap, everything's going to be allocated in the order that space is available, and so you have to keep track of free space. So the PFS page keeps track of the free space available for pages to allocate into. So the allocation process for a new object in Tempdb or in any database is that the allocation goes to a particular file. In that file, we have a GAM page, an SGAM, and a PFS page that helps identify where things are available. So we have the GAM page that's associated with the GAM intervals, SGAM page also associated with the GAM intervals, PFS page associated with the PFS intervals. And using this and reading these 3 pages, SQL Server is able to identify that this allocation is going to occur in database 2, file 1, extent 39, page 312. That's how it actually looks it up. Now, the problem is these pages actually do have to be read. They have to be read by the storage engine, and in order to do that, they take something called a latch. Now, that latch is not something that can be shared. It's something sort of like a lock whenever you're dealing with your regular SQL Server reading process. So if you've got a lot of allocation occurring at the same time, it might be parallel whenever the allocations are requested, but it becomes serial as each of the requests has to wait in turn to read these 3 files. So this can cause something called contention, where each of these requests is waiting on the one in front of it to finish reading these pages. This can add up to a lot of really wasted time and effort. The reason that it's such a problem with Tempdb is that Tempdb has a lot of new objects created. If you think about your workloads for your user databases, you're probably not creating dozens and dozens of new objects. You're probably just going ahead and using the objects that exist. But with Tempdb, you're creating new objects all the time. The solution to page contention is to have multiple files. So whenever you have multiple requests coming in and they're each able to go into a new file, they're each able to get access to their own unique copies of these allocation pages, and that lets things move through more smoothly. Now, the trick is, not only do you have to have multiple files, but they need to be the same size. So when you have multiple files of the same size, allocations occur in a proportional round-robin fashion. 1, 2, 3, and 4 go to files 1, 2, 3, and 4, etc. But if you have one file that's smaller than the rest, SQL Server is going to try to make it catch up to the others by allocating more to that smaller file than to the others. In this case, we would have more allocations occurring to file 1 than to files 2 through 4, and so we would start running into contention on just that one file. So in order to have proper file configuration to avoid Tempdb contention, you need to have multiple Tempdb files, all of the same size. You should pre-size the files to prevent autogrow, because if one of the files autogrows, it is now not the same size as the rest of them. You should set the log size to twice the size of the largest file, and you set the autogrow to a fixed size so that whenever autogrow does occur, which you should be trying to avoid, it's occurring in a fixed interval that isn't necessarily growing over time. The number of files, there's a lot of different ideas on how you need to create your Tempdb files. This is the advice that I give. You create one file for every 2 or 4 logical CPUs up to 8. So if you've got, as my example VM, it has 4 CPUs, maybe I'd set it up with 2 files to start. I would start monitoring for contention to see if a contention is occurring. If it's occurring, I would add 4 more files, do it again and again until a maximum of 1 file per logical CPU. With my little 4 CPU test machine, that means that 1 file per logical CPU is only 4 files. But if you're dealing with something like a 64 or 128 way server, I don't want you to start with 64 or 128 files. I want you to start with 8, monitor for contention, and then move on up from there. Because there's no reason to have all of these extra files and the overhead associated with having extra files if you're not going to be experiencing contention above 8 or so. So 8, 16, etc. might be a reasonable number to test with. Now there are 2 trace flags that can affect behavior of contention. So one of them is trace flag 1117, which causes all files in a file group to grow equally. So that means you can kind of avoid that problem with proportional fill and the one file becoming smaller. You set this trace flag and all the files, when they grow, will grow together. So that can be convenient. And trace file 1118 causes mixed extents to not be used. So all of the files, all of the new objects get their own extent right from the get-go. This is the default behavior for Tempdb in SQL 2016, and so with that in mind, I would say these 2 trace flags are something you might want to consider if you're looking back at running workloads on SQL 2014 and earlier. But these, for Tempdb in SQL 2016, is the default. So when you're monitoring for contention, I want you to check for waits on allocation objects in Tempdb. That's where time is being spent waiting on the allocation object to become free because something else has a read on it. When you're configuring it for the first time or whenever you're reconfiguring it based on some indication of a problem, I want you to check it continuously. And after that, I want you to do weekly spot checks. You'll be monitoring it using SysDM OS waiting tasks, looking for wait types of page latch with one of these particular page IDs. So the PFS pages are a multiple of 8088, the GAM pages are a multiple of 51232, and the SGAM pages are, again, multiple of the page ID -1 is a multiple of 51132, 511232, sorry. Don't try to memorize this. Again, it's in my demos, and we'll cover that in just a second here. So let me pop over to my contention. So this is my monitoring batch for contention, and so what we've got here is a couple of subqueries, CTEs, and this one is just a little query on SysDM OS waiting tasks, looking for resource description like 2, which is the Tempdb file ID, and wait type of page latch. So when I run this right now, I'm not getting anything. Now from that, I have a further query to check to see if it's a PFS, GAM, or SGAM page. I run that all together, and I sum it up so that I can see what's the total wait duration and wait type for PFS, GAM, and SGAM pages. But I don't have any contention going on right now, so I'm going to create some. I've got this little create contention batch, and what it does is we have a use AdventureWorks while loop that just selects data into temp and drops the table and just runs it in a tight loop. And then this batch file just opens 64 copies of that. So I'm going to run this create contention. I'll go ahead and run it twice. So now I've got about 128 sessions running against that server, all making use of Tempdb. So I go back here to my monitoring batch, and here we see we have a 678 millisecond wait duration on the PFS page. As I run this, you can see it going up and down. So this is really a wait duration that this is slowing down all of the work that is occurring across these 128 sessions for no good reason. The way I would fix this would be to put the 4 files back that I don't have set because whenever it was restarted, some of them were set to read only. So this is something that could be very easily fixed, but it's really transparent. There's nothing, you're not getting any error messages, you're not getting anything in here that says, hey, I'm having a problem with Tempdb. You have to monitor to find this. And so when you find this, If you see this sort of contention, there's really no reason to have to put up with it. You can get rid of it by changing the file topology. So I'm going to kill that. And we're going to move on. Have to pardon me while my computer tries to chew through killing all of those sessions. There we go. And I am going to start a workload before we start talking about the next topic. So next up, we're going to cover the transaction isolation version store. So transaction isolation is a solution to a problem of blocking that is used by many developers and many organizations in order to have things run more smoothly in a near non-blocking situation. But it does have some catches. So if you're not familiar, blocking is of course caused whenever you've got a write occurring on a file, or on a record and a page, and you have reads occurring. They can't read while the write is occurring. They're blocking each other. The read is having to wait for the write to complete. So snapshot isolation works by whenever the write occurs, it actually takes the old version of the page, moves it into Tempdb in a space called the version store, and lets the reads occur there until the write operation completes. So this really helps out a lot. You've got version 1, you've got a write occur, and you've got a read occur at the same time. Well, the write isn't completed yet, so we'll just go ahead and read the version that was already available when the read started, and that's going to be stored in the version store. Now the trick is you can have multiple versions. So let's say you've got multiple writes occurring, you've got multiple reads occurring, and they're occurring in different times. So you have a read that starts on version 1, then another write occurs, so now you have a version 2, and another read starts, and so it's reading version 2, and now you've got a version 3. So you can wind up with multiple versions of a page in the version store. In this case, we've got catfish, cat dog, catfish. It's going back and forth. So the Tempdb version store isn't just limited to the amount of space for any of the objects being read. It's the amount of space for those objects being read and all of their changes as they're occurring over time. So the problem is that oldest copy has to be kept in case that transaction needs to do more work, as long as this old read transaction is open. That can occur, that can hold a long time open, and it can cause a lot of growth of the version store. Imagine the situation that somebody started a transaction that was reading something, then they went off to lunch. So they've left it open. It's going to be open for an hour and a half. Meanwhile, all of these other writes are occurring, all these other reads are occurring. The version store is having to keep all of that data just in case when they come back from lunch, they choose to read that page again. And that can cause uncontrolled growth of Tempdb, possibly all the way to filling up Tempdb and bringing your server down. So when you're using the transaction isolation mode, I want you to check the version store size and check for long-running version store transactions. If you've got people who are continuously using version store transactions that are really long, you should talk to them about what their workload pattern is and whether transaction isolation, whether there's a different transaction isolation mode that's better for them. Maybe snapshot isolation isn't the best for that workload. Or maybe it's just a mistake. Maybe they didn't realize they needed to be cleaning up more quickly. I also want you to check the version generation and cleanup rate. I'd say if you're running snapshot isolation, you should check this continuously. So you make sure that you don't have anything growing out of control and causing your SQL Server to fall apart. Otherwise, if you're not running snapshot isolation, check it with your space available check, which I said earlier, maybe hourly. Partly because you don't know if somebody were to go switch on snapshot isolation, and then you would need to know about it, know that it's been switched on, know that you need to start monitoring it. When you're monitoring the version store, there's a couple of special spaces you need to look. In the DB file space usage, we have a version store reserved page count. We saw that at the beginning with the file topology. We also have DMTran active snapshot database transactions, which gives you a list of the transactions which are making use of snapshot isolation. And we have some performance counters. Here I have them listed in DMOS performance counters, but you can also use perfmon to track the version generation rate and the version cleanup rate. Let me give you a demonstration of what that looks like. So when I go over to my system here, I've been Let me show you what I had started earlier. I've got this AdventureWorks 2014, which has Allow Snapshot Isolation on. And in that transaction, in that database, I have this transaction kind of running in a loop that's just updating the list price for this product table and waiting and then continuing. So we've got this workload running and it's constantly making changes to all the pages in my big product table. So if I go over here and take a look at perfmon, I'll show you what we have here. So we are taking a look at the version store size, the version cleanup rate, and the snapshot transactions. So I'll also bring up the version generation rate. You can see it's a little jagged. So this is just as my transaction is running, it's making new versions of all of those pages. It's running faster or slower. It's based on the network, based on page, etc. So that's running through there. As it's making those changes, you can see this blue line is the size of the version store going up and up and up. Now every 1 minute, a version cleanup job occurs, and that's this green line. And so you can see that the version generation rate is staying pretty solid. The version store size is going up pretty solidly. The generation rate is all over the place. But the cleanup rate is going to remain 0 until that cleanup job occurs. So here in a few seconds, we're going to see the version cleanup rate spike as it deletes all of those versions that are not currently being read by anything. And there we go. So now the version store size has dropped all the way back down. So the maximum here, and I guess the minimum 67K and the maximum is about 2 meg. Or I guess that's in K, so it's larger than that. But you can see this is kind of working along like clockwork. So you don't really have to worry about the version store getting any bigger than the maximum that it gets in any 1 minute period. However, you know that I had more to show you than that. I have a long-running version store transaction. So this is a snapshot level transaction that's going to select one row out of that big product table. So just one row, really just one record from one page from that table. And now we've got that one, but we've left it open. So let me jump over and show you what that looks like in the system tables. So what we've got up here is the DMTran active snapshot database transactions. We can see that transaction that I just started, and we can see how old it is. The elapsed time in seconds is 15. Now if I run it again, since a few seconds have passed, the elapsed time in seconds is now 32. Now when this goes above 60 seconds of elapsed time, we're going to start seeing a modification in the expected maximum size of the version store, because now there's something reading it, so the cleanup job isn't going to be able to run because that is being used. This is the version generation and cleanup rate as they appear in DMOS performance counters. I have them listed here, but as you can see, these are counters that you're going to have to cook yourself. So like I take a look at this and run it again, this number down here, 1577208, run it again, 15886. So you really have to do the diff between two of them to see what the rate, and that's something you can do, and certainly most monitoring products can do it, but it is a little bit easier for visualization purposes to jump over there and use perfmon. So let's take a look here. We've got elapsed time in seconds is now 74. So let's jump over, take a look. And yeah, as you can see, our cleanup job hasn't run lately, and what was previously our maximum here, we've now gone at least twice as high. Now this is going to keep going for as long as I leave this transaction open. And we can take a look at what that effect that's having on our file topology as well. So you might have seen, remember this was a 16 megabyte file. It is now 5116 megabytes, of which 5107 is the version store. Now as I run this again, 5409, 5487. This is just going up and up. So I'm going to run out of space before long. This is causing constant auto growth. So we have free space MB of 15. Now we have down to 11, and we've done an auto grow. This is really flailing on that file. So not only do we have this space being used, but we've got autogrow occurring over and over and over, which is slowing down everything that's occurring in your system while that's waiting to happen. So what I have to do is commit that or kill it, and then when I take a look at the snapshot isolation, I can see my snapshot isolation has transaction has cleaned up, but I'm going to have to go ahead and wait. Looks like we timed it just right. So we killed it, and it's dropped down for the cleanup. So that's how you're going to clean. It's going to clean it all back up again whenever you kill that transaction. But meanwhile, your files are all out of whack. So now we're up to 6406 from what had been 16 megabytes. And the version store, it's dropped down in size. It's going to keep causing havoc. I mean, there is going to be some overhead of the version store being used just because I have a version store transaction occurring, but the long-running read transaction was really causing the problem. So when you're monitoring for that snapshot isolation, what I want you to do is take a look at those active snapshot database transactions and take a look at the elapsed time in seconds. I would be a little bit suspicious of anything above 1-2 minutes. Start wondering why it's taking so long. Maybe in your environment there's another number that you need to be worried about, 5 minutes, etc. But you should be checking to see, is there something that's running unusually long? Did someone start something and then go to lunch? All right, so moving on, just quickly, session space usage. So this is kind of the most fundamental issue that people kind of run into. With session space usage, we've got all of these different things that are occurring in Tempdb, and all of these different sessions are using space. So one of the things you can do in order to just improve the running of your SQL Server, improve the running of your queries, is to see how much space any individual session is using in Tempdb, see if you can decrease it. Maybe you're using temp tables you don't need to use, or maybe your use of temp tables is excessive. So one of the ways that you use Tempdb, besides explicitly using Tempdb or temp tables, is something called a Tempdb spill. That's where SQL Server is attempting to allocate space in RAM, doesn't have room, so it instead spills all of those pages to Tempdb, which then in turn spills to disk. So that spilling process brings everything to a slowdown, especially on that query, as it's having to move data around from RAM to disk, back and forth to make extra space. So that's something that you would want to be watching for. And so when I'm talking about monitoring for session space usage, it's as fundamental as I want you to check for heavy use of Tempdb by a user session. It sounds, very basic. You'll have to take a look and see what's heavy in your environment. Narrow down to those particular queries. Take a look and see what's happening. Is it a Tempdb spill? Is it a large temp table? Do we have a large cursor? Or is it really expected behavior? So I want you to check it continuously while you're doing workload tuning. Maybe you've got a server, you're trying to figure out why things are running slowly. Otherwise, just do a daily spot check, get a sense of how much space is being used by sessions in your Tempdb. There are two DMVs for session space usage. One of them is called DMDB session space usage, and the other one is DMDB task space usage. The difference between them is task is the activity that is currently happening. It's still in progress. It's not complete. And session is everything that has happened since that session was opened on the SQL Server. I'll give you a look at what that looks like. So I'm going to go ahead and stop this long-running job here. Make sure it's committed. I'm going to close that up, clean up a little bit, make sure that this is all looking all right. So I've got my little session here set up to use Tempdb. So I've got kind of a three-step process. Step one, I'm going to select into a temp table from my big product table. So this is just a single step going to move some data into Tempdb. The next step, in a loop, 1,000 times, I'm going to do that again. Just kind of keep adding data to it. And then third, I'm going to drop the table. Now each of these go statements indicates the end of a task. So this is task 1, this is task 2 through 1,000, and then this is task 1,001, or 1,002, I suppose. And then when I want to look at the session usage, this is kind of eyeful. But we're taking a look at the allocated and deallocated pages across both session space usage and task space usage. Let me run that and you can kind of see what that looks like. I don't have anything using Tempdb right now, so I'll run this first one. Select 1,000 rows into temp table from big product. And notice that was SPID 55. Now when I run that, I can see session 55 has 33 session user pages allocated and 9 session user pages deallocated. And I can see the task user pages, the session internal pages, the task internal pages. So as I am running this second job, going 1,000, I'm going to see pages being allocated and deallocated at the session and task level. So the current task at the time I ran this query was using 32 pages and had deallocated 8, and that's adding to the running total of 97 pages and 25 pages. Now as I keep going, you're going to see this number keep going up. The task isn't changing because it's just running the same task over and over in a loop, 32, 8. But the session user pages is going to go up and up. That means that you have to use a little bit of judgment when you're reading this. If you get in here and you see a session user pages allocated that's extremely high and a session user pages deallocated that is also extremely high, but the task user pages is not very high, then it might just mean that that session has been open a long time. If I were to be whittling away a few pages at a time, 10 pages at a time, but for fixed days, I'm going to eventually have a large number of both allocated and deallocated pages. Now, if you want to know the current use, you would basically subtract the deallocated pages for both task and session from the allocated pages for both task and session. So you would add this all up. There are some complications to that. You would need to be taking a look at the internal pages as well. I'm not going to go into a great deal of detail on it. It's something that you'll probably get a better feel for while you're working on it. This is something that monitoring tools can help with as well. But basically, I wanted to look in here, and if I see something that's really out of whack, I've got a session ID where the current task user pages is way higher than everything else. I want to go take a look at what's running on that session and what might be causing that, and see if I can just reduce it, and maybe make less use of Tempdb, maybe make better use of cursors or get rid of them, etc. Get everything to run a little bit more smoothly. So I told you we would talk about SQL 2016 later, and now is later. So I said earlier that the best practices were not being followed in SQL 2014 and earlier setup. Now, with SQL 2016, setup has it configurable. So all of the things I've got highlighted in green here are now configurable during the setup process. We've got this new screen that basically has your file count, file location, and both the data and log size and growth factors all available to be set up. So whenever you're setting up your server, there's a server configuration, data directories, and Tempdb tab. You'll want to go over to Tempdb and set that number of files to higher than 1 and the initial size to higher than 8 right from the get-go. Try to set it up to be more appropriate for your workload. The other thing that's new in 2016 is that trace flags 1117 and 1118 are on by default for Tempdb. And for user databases, you can turn this on and off now without using trace flags. It's actually a fully fledged alter database. So you can say alter database set mixed page allocation or alter database modify file group to set autogrow for all files or autogrow on single files. So we're not having to work with kind of the mystery of trace flags and whether or not they're set. You can go for a database by database setting and set this to work the way you want it to. So to review, we covered file topology, contention, version store, and session space usage. And all of these things are really combined with each other. As you're monitoring file topology, you're going to get a sense of whether you have enough files for the type of server that you're running. You're going to get a sense of whether the version store is larger than you need. As you're taking a look at the version store, you're going to be taking a look at sessions that are running, how much space they're using, how much time they've been using the version store. And with contention, you're taking a look at the sort of overhead of weights that you have happening for no good reason because you don't have the file topology exactly where you need it to be. So thank you very much. I'm going to take a few minutes to take your questions.
Okay, so we do have a few questions that came up during the session. One of which would be from James, and he asked, what percentage of the auto growth should be based on initial size?
What percentage of the autogrowth should be based on initial size? So the thing that you want to think of with Tempdb and autogrow is that you don't want it to occur. If it's occurring, then it's kind of an emergency. That's my sense. So you want to go ahead and set Tempdb to be the size that you want it to be and the size you expect it to be. And when you have autogrow, you want the autogrow to occur across all the files either using the trace flags, or you're going to be using 2016 and having it across all the files. And you only want it to occur once, if you can get away with it, to keep the files, from just filling up and the server going down, but you don't want it to be occurring constantly because it's just constant overhead. So I'd say as high as you can put up with would be one way of putting it, but certainly not percentage-based and certainly not very small. So depending on your initial size, if you've got your Tempdb is set to a gig, maybe it's fair to say that the autogrow should be 500 meg. You want it to only occur the once, you want to know about it, and you want to reset your baseline to say maybe that's the file size that I should be setting for Tempdb from the get-go.
Okay, so by your recommendation, auto growth should be left on?
Yes, I would say I have seen the recommendation to turn autogrow off, and maybe that creates a little bit of, reason to monitor more carefully, but to me, the possibility that your files might autogrow and you'll start getting contention is still better than the possibility that autogrow won't occur, you'll fill up and your transactions will start failing or your server will go down. So as long as you're monitoring, I would prefer to see autogrow occur and then you take a lesson from it and try to keep it from occurring in the future than to just not allow it at all.
Okay, perfect. So moving on, we have a question from Kai asking, is Tempdb also used for a select ... order by without supporting index?
I select, it's by an order by? So yes, there's a lot of different things that can, work tables and different plan operations that occur in Tempdb whenever there needs to be areas that things are sorted, we have areas that things are being spooled, and that's going to be going into Tempdb for the most part, so yes. That's the sort of thing you would see reflected in your session space usage as you're monitoring. So maybe you take a look at a query and you say, I don't see how this is using Tempdb. It's not explicitly using it. It may be creating work tables or it might be spooling. So take a look at the query plan and take a look at set statistics IO to see if anything's being created that you didn't explicitly create yourself.
Great. Okay. Janya asks, why do you stop at 8 temp files? What's the downside if there are more than 9 CPUs?
Okay, no, actually I want to be clear. You only stop at 8 files to begin with. So I want to run back to that slide real quick, make sure that I didn't word this incorrectly. When you are starting to monitor, I want you to create one file for every 2 or 4 up to a maximum of 8 for then. So I'm saying I don't want you to create, if you have 128 CPUs, I don't want you on step 1 to create 64 files. I want you to create up to 8 as that first step and then monitor for contention. If contention still is occurring and you've got 128 cores, absolutely go on up from there, add 4 at a time until it stops. So it's completely possible that you could have well more than 8 files. You might have 16 files, you might have 32 files. I couldn't tell you for your environment, but there's no reason to start at that high a number. So start at 8 and see where you go.
Okay. So let's move on to the next one. CJ Morgan is asking about if your desk is in a closet.
Yes, it is. Actually, this is funny. I work from home, and just for space purposes, I put my desk in a closet. Yes, it's a standing desk, and I think you're one of the first people to actually mention it, but yes, it is.
Sorry, I thought that was a funny question. All right, so London DBA is asking, with Tempdb on a high-speed flash array, user query can fill up Tempdb faster than your DMV session and task space monitoring. Are there corresponding extended events that show session and task usage?
So I might have to check that one written, but I think that depending on when you asked that, I might have covered that in the session space usage demo. So we do have the session space used DMV, and then as far as the X event portion of it, I haven't tracked it down because I've really only looked at it from the session space DMV perspective, but it might be. There might be.
Okay. Next question is from Frederick. I've frequently seen suggestions to place Tempdb on a drive by itself. Does this matter at all in a virtual environment where all drives are mapped from the same SAN?
I would say it depends on what you're trying to get for. So if you are separating it, yeah, as you say, if it's all going to be mapped from the same SAN, from a physical I/O perspective, maybe it doesn't make a difference. It might make a difference for your manageability purpose in terms of knowing that this drive needs to have different maintenance characteristics, different size characteristics than your other disks. Maybe it has different backup considerations. So you might logically separate it, and that same sort of logic might occur on other non-user database files. Separately, I have a presentation on system databases, and I do recommend all the system databases get backed up and that they are separated onto non-system drives. So it's not going to give me heartburn if you want to put Tempdb on the same drive as your user databases in a virtualized environment. I would prefer it to not be on the system drive because your VM is still going to get unhappy with you if Windows runs out of space, or and you're unable to boot, or if that Windows host gets hosed, now you're trying to rebuild the SQL server and you're having to kind of move everything around. It'd be better if it was just on a different disk to begin with. Tempdb, though, it is blanked out every time you rebuild it, and so you do want to be aware of the need to have instant file initialization so that you're not having to wait for that file to be created every time you restart.
Okay, so I think we have time for one more question. This looks like an interesting one. You've said that the initial size of Tempdb should be the size of the biggest index. So if the biggest index takes up 70 gigs, should we initially make all files 70 gigabytes?
So no, probably not, but it's possible. So what you want to take a look at is when you are doing maintenance on that index, are you doing it in an online format? Is it happening all at once? How much of it is going to Tempdb? So if when you're doing your regular maintenance jobs, you find that that entire index streams into Tempdb and it uses 70 gigabytes, then the answer is yes. If it turns out that your largest data index is actually, the way that it's being stored, the way that you're doing your maintenance, that is not pushing all of that into Tempdb, maybe you don't even have online rebuild occurring, then maybe not. So if your largest index is a size that gives you some stress about, making Tempdb that size, take a look. Just watch what happens. And if your Tempdb has been getting away with having, 4 gig for, weeks and weeks and weeks, and you've been running your regular maintenance on that index, you're probably okay.
All right, great. Well, that's about the time we have for today.
And just for any additional questions, I will be available on Twitter. I will jump on immediately after this is over, so you can certainly ask me more questions then.
And we'll be forwarding a lot of the questions because we do have a few questions that we weren't able to get to today.
Okay.
So make sure to stay tuned for our next session, using Azure Machine Learning to predict consumer price index with Patricio Cofre. And then thank you for attending, everybody. We appreciate you guys taking the time, and we hope you guys learned.
Thank you so much. Have a great day.
Thank you, Vicki.